All right, ever wanted to be a chemical detective? Well, today's your lucky day. We're going to solve a classic mystery. How do you find something you can't even see hiding in a solution? It sounds tricky, but it's super important for things like checking our drinking water or making sure factories aren't polluting. So let's get right to it.
So, picture this. You've got a beaker of what looks like totally pure water. It's crystal clear. But what if it's hiding something? I'm talking about sulfate ions. They can be a big deal for the environment and even in industrial settings. You can't see them, and that's the whole problem. So how in the world do we find them? Yep, our main suspects today are sulfate ions. And they are sneaky. I mean, they're completely colorless, and they dissolve perfectly in water. So just looking at the sample gets you nowhere. Our mission then is to find a test that's going to force these ions out of hiding. We need something that gives us a clear-cut, undeniable answer. Okay, so every detective needs their toolkit, right? We're not talking magnifying glasses or fingerprint dust here. For this job, we need a couple of specific chemicals called reagents. And a reagent is just a fancy word for a substance you add to something to see if you get a reaction. It's our truth serum for chemicals, if you will.
And here they are. Our whole toolkit fits in 2 little bottles. First up, we've got dilute hydrochloric acid, or HCl. Think of this as our way of clearing the scene. It gets rid of any other ions that might try to confuse us. And then, the star of the show, dilute barium chloride. This is the one that's really going to expose those sulfate ions. That's it. Everything we need is right here.
All right, let's get to the action. The best part about this test is how simple it is. Seriously, it's just a quick 3-step process. You follow these steps, and you're going to get a result that leaves 0 room for doubt.
So here's what you do. Step 1. Add a few drops of that hydrochloric acid. This step is super important because it gets rid of other ions, like carbonates, that could mess up our test and give us a false alarm. We don't want any red herrings, right? Okay, step 2, add a few drops of the barium chloride solution. And then, step 3, well, this is the fun part. You just watch. And this is it, the moment of truth. If those sulfate ions we're hunting for are actually in that solution, something is about to happen that you just can't miss. It really is the chemical version of a smoking gun. So, you've done the steps. You're staring at the test tube. If those sulfate ions are lurking in there, what happens next?
Just like that, a white cloudy solid appears out of nowhere. It forms right there in the clear liquid. That stuff is called a precipitate. And seeing it, well, that's our positive result. That's how we know. The mystery is solved.
So what is that white cloud exactly? It's a compound called barium sulfate, and the reason we can see it is because it's what we call insoluble. It doesn't dissolve in water. Think of it like sand in water. It just won't disappear. So the second those barium ions we added meet any sulfate ions in the sample, they grab onto each other, form this solid, and boom, we can see them.
Okay, so seeing it happen is cool, but let's be real, we want to know why it happens, right? Let's break down the actual science behind our clue. This little equation here tells the whole story. It's called an ionic equation. You see the barium ion and the sulfate ion? They both have AQ next to them, which just means they're dissolved in the water. They're our invisible suspects. But when they meet, bam! They form barium sulfate, which has an S for solid. And that solid is our white precipitate.
And this chart here shows the whole shebang. Let's pretend our original sample had magnesium sulfate in it. When we add our barium chloride, it's like a big partner swap. The barium ions ditch the chloride and pair up with the sulfate ions. That's our solid precipitate. So what happens to the magnesium and the chloride? Well, they just become partners and stay dissolved in the water. Easy peasy. So here's the bottom line. When you do this test and you see that white stuff form, that's it. That's your proof. It is a 100% reliable sign that you had sulfate ions in your sample. Case closed. You know, this test is just a great example of how chemistry lets us see the invisible. A simple reaction like this can help protect our water, our health, the whole planet. It kind of makes you think, doesn't it? What other secrets are hiding in the world around us, just waiting for the right chemical test to reveal them?